Hey everybody, today's video is on chapter 9, the first section, 9.1.1. So in our unit 10, we're talking about chapters 8 and 9, so that's why we're switching gears to chapter 9. Next week, we'll definitely review yesterday's lesson, and if you take a look at today's Google Classroom, there's also a video I found on my YouTube channel from 4 years ago that talks about operations with scientific notation. So I thought that might be another good resource for you guys to review what yesterday's was if you wanted. Today we're talking about parallel lines and angle relationships between them. So really going back to reviewing chapter 8 of CC2 and building on that. So we're going to be able to establish facts about angles formed when parallel lines are cut by a transversal. The form that I have will go here. It's going to be a pretty short one today. Just some notations that you need to remember. The little arrowheads at the end of lines indicate that they extend indefinitely, so the lines can go on and on and on. And these little marks inside, like that, indicate that the lines are parallel to each other. So if you see that, that means the two lines are never going to intersect. And the small box at the point of intersection of lines means that the line segments are perpendicular. They form right angles. So that little box there, you already know it means a right angle. That also lets you know that the two lines forming that are perpendicular. Now we're going to talk about transversals. So a transversal is basically just a line that is cutting through or transversing through two other lines. They could also intersect more than two lines at different points. But basically, this line here, R, is a transversal through the two parallel lines S and T. Now, line W over here is a transversal through lines X and Y, but you'll notice X and Y in this case are not parallel, but W is still a transversal because a transversal is just a line that cuts through or intersects two other lines. Now we can use these information to try to find missing angle measures. So I found all the other missing angle measures for figures 1 and 2. Kind of ran out of room, so I didn't write down for figures 3, but I'm hoping that can be something that you pause the video. I'm just going to tell you the answers to those. So figure 1, we're given that angle A is 107 degrees. Now, knowing what you know about vertical angles, that also means that angle C, since it's sharing a vertex, is going to also be 107 degrees. And now because of supplementary angles, which are two angles that add up to 180 degrees or form a straight line, supplementary straight, we can find angle B by subtracting 180 minus 107, and that will give us 73 degrees. Now you'll notice B is 73 degrees, and if we look down here on the other line that's parallel to line P and cut by the same transversal, we see 73 degrees. And we know that D and E are supplementary. They form 180 degrees, so 180 minus 73 does equal 107, which is the same measure as angle A. And so we can see some different angle relationships there. And I did write D as corresponding. D is corresponding to A, and B is corresponding to E, really. Now in figure 2, we're given that G is 152 degrees. We know that F and G are supplementary again, so we can take 180 minus 152, and that will give us 28 degrees for F. F and H are vertical angles, so we know that H is also going to be 28 degrees. And then when we go down here and the other parallel line, but this transversal, we see that J is 28 degrees, which is what F and H were. And K is going to be supplementary to J, so we could do 180 minus 28 to give us 152 degrees. And that also shows that K is congruent to G at also 152 degrees. Now in figure 3, it just looks slightly different because our parallel lines are going diagonal kind of this direction, and our transversal is a straight line this way. So line M is still the transversal, P and Q are parallel, given by these little dots. So N being 41 degrees is vertical to W, so we know W is also 41 degrees. and it's supplementary to r. So we would take 180 minus 41, and that will give us 139 degrees. And if we look over here at t, these angles r and t are in the same side of the parallel line in the same location of the transversal. Okay, so they're to the right of the parallel line and above the transversal. So they're in the same spots, which makes them corresponding angles. And S then is supplementary to the 139, so we'd subtract from 180 and we get 41. But there's another relationship between the um, angles here. 41, we can say this N is corresponding to S, and T is corresponding to R. So there's lots of different ways we can look at finding these missing angle measures. Corresponding angles, I have already mentioned that, but here's the actual definition. So they're angles that are on the same side of two lines and on the same side of the third line that intersect the lines, which are corresponding angles. So 1 and 2 here are corresponding because they're in the same location from each of the lines. Okay, and then 3 and 4. Also, if we had an angle right here, it's going to be corresponding to this angle right here, and the spot is corresponding down here. Okay. Now, what we know about corresponding angles, the reason we're learning about them is because they're equal or congruent, and that gives us a lot of good information. So here we can see these diagonal angles because they're 1 corresponds to 2 and 3 correspond to 4, and 1 and 2, 3 are vertical and 2 and 4 are vertical. All 4 of these angle measures are the same, okay, which means the other 4 that aren't listed here are also the same. So in any given situation when we have 2 parallel lines cut by a transversal, we're really only dealing with 2 different angle measures at the most, unless it would be, parallel lines and then the transversal is perpendicular, then all 8 of the angles would actually be the same. Alternate interior angles are basically, they're the angles where they're both inside the parallel lines. So if you looked inside the parallel lines, okay, they're angles on opposite sides of the transversal. So 1 and 2 are alternate interior angles, and X and Y. Now, something this lesson is not talking about yet are also something else called alternate exterior angles. So interior means we're inside the parallel lines. Exterior means we're going to be outside of the parallel line. So that would be if I had an angle measured right here, the alternate exterior angles up over here. And just like alternate interior angles being equal, alternate exterior angles are equal as well. That's just another special relationship that we can see. Now, there's also one more called the same side interior angles. And so what that means is 2 angles that are on the same side of a transversal and between. So they're not alternate interior, so they're still interior angles, but they're on the same side. They have a sum of 180 degrees. Okay, so that would be like angles 3 and 5 here, or angles 6 and 4. Both sets of those are examples of same side interior angles. Now, our challenge question for you is to, if you know in this whole relationship that the measure of angle 5 here is 110 degrees, we want to know what are the measures of the other 7 angles. And so you could pause and kind of jot your answers down, or at least think about your answers before going on to the next slide, which has the answers on it. So 5 again was 110 degrees, and there's a lot of different ways we could explain this. So I have written down one of a set of probably a lot of different possible ways we could explain these. So I started with 5. I know 5 and 1 are vertical angles, so I know they have the same angle measure, so 1's also going to be 110. Now, I could have chosen a different route than what I have written here, and I could have said right away now that angle 6 is also 110 degrees because it's corresponding to angle 1. Here's a parallel line, 1 is below it and to the right of the transversal. When I go up to the other parallel line, the line or the angle that is below it and to the right of the transversal is angle 6. So they're corresponding. So 6 is also 110. And then 7 is vertical to 6, so it's also 110 degrees. And those are my four angles that are congruent. And then I could look at, well, I know 8 and 7 are supplementary, so 180 minus 110 is 70 degrees. And I know 8 and 3, those measures of those angles are vertical angles, so 3 is also 70 degrees. I know 3 and 2 are corresponding angles, so that also has to be a 70-degree angle. And 2 and 4 are vertical angles, so that's also a 70-degree angle. So there's a lot of different ways. What I explained is different than what I have written. So you could take some time to read that as well by pausing the video. Now, I believe that's really all I had for the video portion. And then I will, in the form, have a couple different problems like this, where I'm asking you to find different angle relationships. And then there'll be some pictures of different angles, and you're going to have to classify them, whether it's showing a pair of corresponding angles, alternate interior angles, same side interior, straight, or none of those, if there's not really a relationship. So that's what will be on your form. Have a great day.